Okay, so let's take a look at something called, very important theorem, intermediate value theorem. Very important. It's in 2.5 for specifically this reason, for continuous functions. IVT, intermediate value theorem for continuous functions. I like a variation of this instead of the general situation. We can talk about both. So here's an example of a function. I have the interval a comma b. Can you please tell me if this is a continuous function? At least on the interval a comma b.
Yeah.
Very good. Is continuous on the closed interval a comma b. We already see it. That's how I graphed it. So obviously the function is continuous on this interval. Can you give me the sign of f of a? Is f of a positive or negative? Just the sign. Negative. Is f of b positive or negative?
Positive.
Very good. So here's what the theorem says. If a function is continuous on an interval, a comma b, and it changes sign from negative to positive or from positive to negative, so here's the first hypothesis. Function is continuous. This second hypothesis says, basically in plain English, it changes sign on a comma b, then by IVT, of course you know me, I like these symbols, there exists a C, I will find a C in, so this is another symbol that I did not show you before. There exists a C in the interval, in whatever, the open interval a comma b, such that f of c is, look at the graph and tell me what it is. What does f of c equal to?
0.
Exactly. So what does this theorem say in our example? It says, if the function is continuous and it changes sign on this, continuous on this interval, and it changes sign on a comma b, it's guaranteed that it has a solution. It has an x-intercept or a 0 between a and b. There exists a c in the open interval, not at a and not at b, the open interval a comma b, such that f of c is 0. So this is extremely helpful. However, what is the problem with this theorem? Here's the problem. It does not find C. We have to wait till chapter 4, and we will be using this theorem with another theorem that we will learn in chapter 4, and we will be able to find C. But the problem here is, it just says, if it's continuous, if it changes sign from negative to positive or from positive to negative, it has to, because it's continuous, it cannot jump over the x-axis. It has to cross. It has to have an x-intercept somewhere between a and b. That's all the theorem is saying. And if you say, what is it? I don't know. The theorem does not give us C. It guarantees that C exists, but it doesn't tell us what it is. And I like to practice this theorem with a couple of examples. Let's take a look, and I'll let you choose. I'm sharing my screen. So the IVT is right here. Use the IVT to show that there is a solution of the given equation in the specified interval. And notice something very important, because the next set of problems does not give us the interval. We don't have to go to anything sophisticated, but we're going to choose a problem, or we make one up ourselves to without the interval. Okay, notice what is very important here. The interval is always 1 unit of 1 unit length. Not between -1 and 10, not between 2 and 5, not between 0 and 5 or 0 and 10 or whatever. The length of the interval is 1. It can be smaller, but not bigger than 1. So please choose whatever you want to work on.
$58.
58. So in 58, we have sine x equals x squared minus x, and the interval is 1, 2. When we talk about sine, 1, 2 means radians. So in calculus, please make sure your calculators are in radians. Okay, so we are given this equation, and we're asked to show that there exists a solution between 1 and 2. Okay. In step number 1, we have to identify, because it's not clear, right? Identify the function in the problem. This is our first step, to identify the function in the problem. What do I need to do? Just remember, this is our target. Everything has to look like this. What do I have to do first? In order to identify, exactly. Move x squared to the other side, move negative x to the other side. So sine x, it was positive, now it's negative. It was negative, now it's positive. Equals, I have to have something here. What is it? I know it's silly.
0.
Of course. In number 2, the first hypothesis. If it's not continuous, the IVT fails. I can't apply it. Is sine continuous everywhere?
Yes.
Is x negative x squared and x, are they continuous everywhere?
Yes. Yes.
So they are continuous. So this is my f of x. F of x equals sine x minus x squared plus x is continuous on, it's everywhere, but we are specifically interested in 1, 2. Not the open, that's where C is. C is in the open, but F has to be continuous on the closed interval. Number 3, let's take a look. What do I have to calculate?
F of A and F of B, so F of 1 and F of 2.
Good. Remember, because we are talking about sine, 1 and 2 are in radians. Careful on that. Good, so I'm going to go to my calculator. I lost you guys. Okay, I found you. Okay, so go to y equals, clear. Make sure to click on the mode and make sure that your calculator is in radian mode. If it's in degree mode, come back and highlight radian mode and press enter. And now I can't unplug this for a second. Okay, so in y equals, I'm going to type in sine x, close the parenthesis, minus x squared plus x. So sine x minus x squared plus x. Now I'm going to plug in 1. So second and table, I plug in 1, enter, and I plug in 2, enter. I don't care for the number. Can you tell me what sign does f of 1 have?
Positive.
Very good, that's all I need. Positive. What sign does f of 2 have?
Negative.
Good, awesome. So from, this was just the first step, from 2 and 3, by IVT, what? What do I write? There exists a C in the open interval 1, 2, such that f of C is
0.
That's it, because the function is continuous and it changes sign. If it's continuous and it changes sign on the interval 1, 2, it has to go through 0. There must be a C somewhere where f of C is 0. Any questions? Do we understand this theorem? The IVT? What if I have, if, let's say, 2x squared minus 3 sine x plus equals 0. I just made it up. We're not given an interval. And we are asked, use the intermediate value theorem to find an interval of 1 unit length, not more. 1 unit length, where the function has an x-intercept. What do we need to do first? What do you think? What will be the first step?
Determine if it's continuous.
Yes, but we have to find an interval, right? We have to find an interval where, yes, you're right, of course I have to show that the function is continuous, but I have to find an interval where the function changes sign. Agreed? Yes?
Yes.
Okay, so I'm changing the function a little bit. I'm going to put a -1 here and 0. So they're asking us for this function, for this equation, find a 1 unit interval where there exists an x-intercept. The reason why I wanted to make one up is because the book gives us the interval for all situations. And let's say we don't have an interval. They're not giving us an interval this time. And yes, you're completely correct. In step number 1, I'll have to say that f of x, which is 2x squared minus 3 sine x minus 1, continuous everywhere. Okay, in step number 2, I have to find an interval where the function changes sign. How do I do that? I'm going to share my screen. So I plugged in the function in the graphing calculator in y equals. I have 2x squared minus 3 sine x and minus 1. That's what I just did. And then we're going to go to second and table. And I'm going to plug in some numbers. I don't really have to, because at 1 is a negative number, 1 unit length, 1 unit interval of 1 unit. The interval has to have not more than 1 unit in length. So I already have it here from the previous function because I plugged in 1 and 2. So obviously there is an x-intercept between 1 and 2. That's all I needed to find. So I'll say 1, 2. I'll go back and write that f of 1 is negative, f of 2 is positive. That's all I need. And what if I didn't get this? I would have started with -1 and then 0 and then 2 and then 3, and I would find it. I'll guarantee you that a problem like this on a test, you're not going to find a solution between 10,000 and 10,001. Of course not. It's going to be an interval somewhere around 0. You're not going to have to look too far. Okay, so that's all we needed to do. And I will write by.
Question, please.
Yes.
So we always need to use the calculator to find that, right?
It will be more difficult to do it by hand. Yes.
Okay.
Yes. By IVT from 1 and 2, there exists a C in the open interval 1, 2, such that f of C is 0. Again, the problem with this theorem is that C is not determined. IVT guarantees there is at least one, but it doesn't tell us what it is.